Hello, hello. Am I audible and is my screen visible? Can anyone please let me know if I am audible and is my screen visible? Hello, hello. Okay.
There is lot of disturbance.
Yeah, disturbance is due to the ceiling fan, which I can't remove. That disturbance I can't remove. You have to bear with that. But can you hear my voice properly? There might be some noise, but if you are able to hear my voice properly, then we can start. Okay, so good evening everyone. Welcome to this NPTEL live session for the NPTEL course Deep Learning IIT Ropar. My name is RNNs. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my 11th live session. We will discuss some practice problems on week 11 topics, which were mainly the recurrent neural networks and different variants of recurrent neural networks like LSTM and gated recurrent unit. So these were the your voice is breaking a lot. I can't hear your voice properly. Can you write your query in the chat?
I'm saying
Week 10 there was a session, so I requested NPTEL to shift my session to Tuesday, and it was held Tuesday.
Yeah, that was week before, 1 week before. Last week there was
No, there was a session. I conducted the session on Tuesday. Instead of Monday 6 to 8, I conducted my session on Tuesday 6 to 8. Another session was there on Tuesday 6 to 8. Some other TA was conducting that. So my session was on Tuesday 6 to 8 last week because I had some work on Monday, so I couldn't take this session on Monday, so I conducted it on Tuesday 6 to 8. And also you can access the recorded session from that PMRF live session TA sheet, so that you can have that link. So through that you can, if you missed that session, you can go to that link and watch the session on YouTube. It is already uploaded. But I conducted the session, only one or two students joined. Most of the students didn't join. Possibly most of them didn't get the email notification, I think.
Yeah, there was no email notification and there was no announcement on the phone.
Yeah, email notification. A notification was sent on Sunday that the Monday session will not be held. It will be postponed to Tuesday. But for the postponed session,
Actually, that was 1 week before. So
I can't hear your voice at all. I mean, it's breaking a lot.
I am saying your session was on Tuesday for 2 weeks.
No, last Tuesday I had my 10th live session on last Tuesday 6 to 8. So last Tuesday I had my session from 6 to 8, and because I had some work on Monday. But it is on YouTube. You can go to my YouTube channel and there it is already present. So we can start today's session. This is the first question. We construct an RNN for the sentiment classification of text, where a text can have positive sentiment and negative sentiment. So there are two possible classes for the output, positive and negative. Suppose the dimension of one or encoded words xt is r to the power 50 into 1, and dimension of the state vector st is r to the power 200 into 1. What is the total number of parameters in the network without biases? So don't include biases in the total number of parameters, only the weight matrices. You have to consider only the weight matrices. Then what will be the number of total parameters in one recurrent unit, one RNN unit? Oh yes, Bandhana, you are right. So I postponed the session 2 weeks ago, not the last week. So you are right. On the last week, I had my session Monday only from 6 to 8, but the email notifications were not sent to all the students. So that's why most of them didn't join. I postponed the session 2 weeks ago, not the immediate previous week. So you are right. But the video lectures are already in the.
Last week we didn't get the email, so I thought there's no class.
Yeah, you are right. So last week I had the session Monday only, but the NPTEL from the NPTEL, no one I think got the notification for some reason. In the course web page it was posted, but email notifications were not sent last week. I also noticed that, but this week email notifications were sent. You can write your answers in the chat. So to compute this, you need to compute number of parameters in three different matrices. So if you go through the equations, how ST is computed from the previous so ST is some sigma of W ST minus 1 plus U XT plus B, which is a bias, so we are ignoring bias at this point, this, and then the output YT is YT is some activation function into V of ST. So W, U and V, these are the three weight matrices we have. So we have to compute dimensions of each of these, which will give us number of parameters. So for W, ST is of dimension 200 into 1, so W has to be 200 into 200. U is multiplied with XT, which is the input. The input dimension is 50 into 1, and this ST is 200 into 1, so U must have 200 into 50 parameters. And V, so Y, this is the output, it has two classes, so dimension is 2 cross 1 for Y, and ST we know that it is 200 into 1, so it should be 200 into 2. So you just have to multiply this and add this value. So this is 40,000, this is 10,000, this is 400, so it would give you 50,400. So these are the three types of parameters you have. So you have to compute the number of parameters in each of these weight matrices. First one is from this W is from ST minus 1 to ST, and U is from XT to ST, and V is from ST to YT. So this is how you have to compute the total number of parameters in a recurrent neural network unit. So is there any doubt in this question? So we can move on to the next question. Which of the following is a formula for computing the output of an LSTM cell? There are four options. Which formula is for computing the output of the LSTM cell? Vandana says option A. Okay. Anyone else? Anand says option D. Okay. The correct answer is option D. HT equals OT into tan H of CT. So instead of tan H, you can have other activation functions as well. But so HT is the actual output of the LSTM cell. So this, even though this OT is called the output gate, so but that is a gate, that is not the actual output of an LSTM cell. So the OT is the output gate. So this is output gate, but this is the actual output of the LSTM. So the gates are there in LSTM to control how much information should flow to which part of the LSTM, but these gates are not the outputs of the LSTM, whether it's output gate or forget gate or the input gate. So these are not outputs, these are internal for internal computation of the LSTM cell. So this output gate is used in computing the actual output of the LSTM, this OT into tan H of CT. So this output gate is used to compute how much of the cell state should be given as output. Cell state is this CT. So this HT is the actual output of the LSTM cell. And OT simply computes how much information of CT would be given as output. So the OT controls that. OT is the output gate here. Now question 3. A statement is given that LSTM can solve both vanishing and exploding gradient problems, which occurs in RNN. So true or false? Anand says true. Okay. Vandana says false. Any other answers? So the correct answer is false, that LSTM can solve the vanishing gradient problem, but it cannot solve the exploding gradient problem, which is also shown in the video lectures why it happens. So it solves the vanishing gradient problem with the use of different gates. So the gates are there to control how much information should be passed on to the next time step and the next cell, or even to the output. So using that, vanishing gradient problem can be solved, and the mathematical foundation is also given in the video lectures, how it solves the vanishing gradient problem. So but exploding gradient problem cannot be solved by LSTM. The exploding gradient problem still remains in LSTM, and by making an RNN unit and LSTM unit, it doesn't solve the exploding gradient problem, but the exploding gradient problem can be solved using gradient clipping. So we clip the gradient values with a cutoff, if with a max cutoff basically. So the gradient values cannot overcome those values, so that the gradient values remain small, even though the gradient during back propagation flows backward, but the multiplication of the gradients would not make it huge, so the gradient values would not explode. So that is the gradient clipping method, which can be used in LSTM, but LSTM itself cannot solve the exploding gradient problem, but it can solve the vanishing gradient problem that we see in RNN. So the correct answer here is false. Now question 4. Which of the following is true about LSTM and GRU networks? LSTM networks have more gates than GRU networks. GRU networks have more gates than LSTM networks. LSTM and GRU networks have the same number of gates. Both LSTM and GRU networks have no gates. Anand says option B, that is GRU networks have more gates than LSTM. Okay. Bandhana says LSTM networks have more gates than GRU networks. A. Option A is the correct answer. LSTM networks have more gates than GRU network. So in LSTM we have the input gate, output gate, and the forget gate. So these are the three gates that we have in LSTM, and whereas in GRU we have two gates. So reset gate and update gate. These are the two gates that we have in GRU. So in GRU we don't have the forget gate, and the forget gate is tied to the reset gate or the input gate actually. So that's why forget gate is not used in GRU. So GRU using this technique they can reduce the number of parameters in the network and also number of gates in the network. So GRU has two gates and LSTM has three gates. So LSTM networks have more gates than GRU networks. Now question 5. Arrange the following sequence in the order they are performed by LSTM at time step t. So these are the three operations: selectively read, selectively write, selectively forget. These are the three operations that are performed by LSTM at any time step. So you have to arrange these three operations into the correct order. In which order these three operations are performed in an LSTM cell. Vemuri Saraswati says option D. Okay. Bandana says option C. Anand also says option C. Anyone else? Correct answer is option C. The LSTM cell first selectively reads the data, that is through the input gate, and then selectively forget operation is performed through the forget gate, and finally selectively write operation is performed through the output gate. So first read, then forget, then write. So this is the correct order of these operations. So option C is the correct answer. So the selective read operation happens through the input gate, and the other parameters are the input xt and the ht minus 1, the hidden state of the previous time step. And in the forget gate, in the selective forget operation, the forget gate is used, and along with that the input and the ht minus 1, these are also used, and also in write the st cell state is used along with the output gate. So option C is the correct answer. Now question 6. The equation for the output gate for LSTM cell is, where U and W are the weight matrices, B is the bias, xt is the input at the particular time step t, and ht minus 1 is the previous cell output for the selective write, and sigma is the sigmoid function. So you have to find which equation out of these three is the correct output gate expression for LSTM. Vandana says option B. Okay. Anand says option B. So the correct answer is option B. So the output gate takes two inputs, xt, which is the actual input to the LSTM, and ht minus 1, which is the output of the previous time step cell, ht minus 1. So other two options are not right because we don't have this ht minus 1 here, which should have been ht minus 1, and here in the third option it is xt minus 1, which is also not correct. So in each of the gates in LSTM, whether it's output gate, input gate or forget gate, each of the gates are functions of ht minus 1 and xt. So every gate is a function of ht minus 1 and xt. So whether it's output gate or forget gate or input gate, each of these are functions of ht minus 1 and xt. Question 7. What is the primary advantage of recurrent neural networks in handling sequential data? So there are four options. They can only process fixed length sequences. They have no memory of previous time steps. They can model dependencies across time steps. They are faster than other neural network architectures. Anand says option A, which is they can only process fixed length sequences. Vandana says option C, they can model dependencies across time steps. Anyone else? Correct answer in this question is option C. They can model dependencies across time steps. So option C is the correct answer. So option A says that it can only process fixed length sequences, which is not true. That is one of the important features of RNNs, that it can process sequences of any length. That's why it takes sequential data, that it doesn't have a fixed sequence length, and it can take any sequential data of any length as inputs, and that's why option A is not correct. Option B says they have no memory of the previous steps, which is also wrong. So while computing the hidden state, st is a function of st minus 1 comma xt. So this st minus 1 is the cell state of the previous time step, that is carrying the memory of the previous time step. So it has the memory of the previous time step, which is carried forward to the next time step t. So it has memory. So option B is also not correct. And option C says that they can model dependencies across time steps. Because of the same reason, option C is correct, that it carries forward the memory of the previous time step st minus 1. This hidden state is carried forward to the next time step t. So due to this, it can model dependencies across time steps, because st is a function of the previous time step st minus 1 and xt. So it can model dependencies. So option C is the correct answer. Option D says that they are faster than other neural network architectures, which is apparently not true. So multilayer perceptrons are much faster. Even CNNs would be much faster, because the number of operations taking place is much lesser than the number of operations that take place here, because here you have to process data through time along with the forward propagation. So it is not faster at all compared to CNN and multi-layer perceptron neural networks. So option D is not correct. So option C is the only correct answer. Now question 8. Consider the dimensions of different components of a forget gate. So forget gate FT in a LSTM unit. So these are the different components how you compute FT. XT is required, which is a 100 into 1, which is of dimension 100 cross 1. HT minus 1 is of dimension 200 cross 1. WF and UF, these are the two weight matrices WF and UF for the forget gate, and their dimensions are 200 into 200 and 200 into 100 respectively. So what will be the dimensions of the forget gate FT using these inputs and their dimensions? Bandhana says option B, which is 200 into 1. Okay. says option C, 300 into 1. So Ft is computed as sigma, which is an activation function of Wf Ht minus 1 plus Uf Xt plus B. So B is the bias, so we can ignore bias for now. So this is how it is computed. So Wf is of dimension 200 into 200 and Ht minus 1, so this is 200 into 200. Ht minus 1 is 200 into 1. So if we multiply Wf with Ht minus 1, so we will get 200 cross 1 matrix. Similarly, Uf has a dimension of 100 into 1 and dimension of Xt, this is 200 into 100. Dimension of Uf is 200 into 100 and dimension of Xt is 100 into 1. So if we multiply Uf with Xt, the dimension of the product would be 200 cross 1. So 200 into 1 and 200 into 1 in both the cases. So Ft will have a dimension of 200 into 1. So option B is the correct answer. Ft belongs to r to the power 200 into 1. So you just have to multiply Wf with Ht minus 1, or you can also do it similarly by computing the multiplication of Uf and Xt and check what is the dimension. And this sigma or the sigmoid function, the activation function, doesn't have any importance here. It doesn't affect the dimensions. So you simply have to compute what is the dimension of this product matrices, Wf Ht minus 1 or Uf Xt. So the correct answer is 200 into 1, option B. So these were the practice problems that I wanted to discuss in this live session. Now if you have any other questions or queries, you can ask me. If there are no questions or queries, then we can end this live session for today. Thank you everyone for joining, and we will again meet next week.
Thank you.
Thank you.
Thank you, sir.
Thank you.